So coming to the next type of special concrete, which is high strength concrete. In this class, we are going to see the details on what is high strength concrete and how it is emerged and what are the technologies and manufacturing methods of high strength concrete. So basically, the high strength concrete origin dates back to 30 years ago, maybe 1970s. So, and during that time, concrete is said to have a compressive strength greater than 40 megapascal. Then it was said to be called as high strength concrete. But now, in the recent, after the 2000 years, then it has been that the compressive strength of the concrete is above 50 to 60 megapascal. It is termed as high strength concrete. This has been the threshold provided by the American Concrete Institute. So mostly the high strength concrete will be used in high-rise buildings and long span bridges in the world, and mostly we could see that there are lots of admixtures which are being used in the high strength concrete to obtain the high compressive strength. So that is the nature of the high strength concrete. Now coming to the difference between the high strength concrete and the normal concrete. As mentioned, the strength will be greater than 40 megapascal. For regular concrete, it goes up to 35 megapascal. Permeability is low in case of high strength concrete, and because we are using a very low water cement ratio in case of high strength concrete, of the range of 0.3 water cement ratio is being used, and super plasticizers are used for increasing the workability, whereas in regular concrete, we use a normal water cement ratio as 0.4 to 0.5, which is normally used. So we have adequate workability. So there's no necessary, not mandatory to use the super plasticizers. And the more cement content is used in high strength concrete, whereas in regular concrete, we use less cement content. Maximum size of the coarse aggregate is reduced in case of HSC, and maximum size of coarse aggregate is more than that which is used in HSC for regular concrete. And mostly, when we plot the stress strain curve of high strength concrete, we could see that there is a steeper and linear to a higher stress strength ratio, because initially the high strength concrete gains lots of strength in the initial days itself. So we can see a steeper curve, and the failure is more brittle in nature for HSC, whereas in regular concrete it is elastic, and durability is increased in high HSC due to the less permeability features. And here in regular concrete, the durability is higher than the less than the high strength concrete. So now seeing the differences, we could understand that the high strength concrete is being achieved by reducing the water cement ratio, increasing the core cement content, and reducing the size of the coarse aggregates and increasing the size of the fine aggregate. So this is the strategy which has been used for making the high strength concrete. So the factors we need to understand, what are the factors that are needed to be considered while manufacturing this high strength concrete. So the first one is reducing the porosity. So how this porosity is reduces in the concrete matrix is that by the usage of this lesser size of aggregates and more amount of cement content and the aggregate cement bonding. So with these three phases, the porosity is being reduced. And the second factor is we are reducing the water cement ratio for the high strength concrete. It should be about around 0.3. The water cement ratio should be 0.3, and this will reduce the workability. But to enhance the workability, we are using water reducing admixtures like super plasticizers. Next, we have this reducing the maximum size of the coarse aggregate. So this will help in additional bonding and reducing the porosity. So the maximum size of the coarse aggregates are being reduced to some around 10 to 20 mm only. So that is one other strategy which is used for preparing the high strength concrete. And next we have this increasing the fine aggregate size, because the fine aggregates having fineness modulus of 3 points are taken as are used for this preparing this high strength concrete. The reason is that the finer particles, HSC already has finer particles in sufficient quantity like cement particles and pozzolana. So hence, more fine particles will not contribute much to improving the workability of concrete, because cement is already added in additional content, so more finer particles will not help. So we are going for making the fine aggregates even coarser, so it will help in workability. If more finer particles of the are added, what happens is that the workability gets reduced, so it's not easy to mix the concrete. So we are reducing the increasing the size of the fine aggregate. This is one another factor which needs to be considered. And the next one is cement content. As said, the higher cement content is being used. In normal concrete, we use around 380 kilogram per meter square of cement content, whereas like 380 kilogram per meter cube of cement content is used, whereas in high strength concrete, we use up to 600 kilogram per meter cube. So more than that, if it goes, the drying shrinkage property occurs, and it increases the heat of hydration of the cement, due to which drying shrinkage occurs in the concrete. So we have to restrict ourselves to addition of up to 600 kilogram per meter cube of cement only. So these are the factors which we need to consider while manufacturing the high strength concrete. Yeah. Now coming to the techniques on how this high strength concrete can be manufactured is, we have around 6 techniques, which is seeding, revibration, high speed slurry mixing, use of admixtures, inhibition of cracks, and sulfur impregnation. So through these methods, high strength concrete can be manufactured. Seeding is, we are adding a small percentage of finely ground and fully hydrated Portland cement particles to the mixed fresh concrete. The fresh concrete will be mixed. Then we are adding small percentage of finely ground hydrated Portland cement. So this will help address the pores, and the porosity will be reduced, and the cement which is added later on with the fresh concrete increases the strength. So this is how seeding method is being adopted for manufacturing high strength concrete. Next is revibration. Revibration here means having a controlled vibration, because when the water is being mixing the water with the concrete creates continuous channels of capillary water in it. So this helps, means it does not indicate that the water accumulates in some places. So this accumulation of water should be stopped. So if that is stopped, the entire voids and the pores are being evenly distributed, and it will be mixed well, and the concrete will be having adequate materials in it. So controlled vibration will help in the concrete to gain the strength. So this is one another technique which is being used. Next is the high-speed slurry mixing. In this, we are making the cement and water mixture as slurry. Then it is being blended vigorously with the aggregate to form the concrete. So vigorous blending of cement paste enables efficient hydration of the cement. So this is one thing which is another method, like mixing the cement and water slurry in a high speed vigorously, so that the entire concrete contributes for a higher strength. This is one method. Next, we have the high strength concrete admixtures usage. So here, admixtures like superplasticizers are being used to increase the workability, as well as to improve the strength of the concrete. So this has been another method for making the concrete. And next is inhibition of cracks. So if we stop the formation of cracks, then the strength of the concrete will be increased. So in this case, the cracks are being inhibited by the usage of polythene or polyester fibers or lenticels, which arrest the cracks, and which needs extra, it adds extra strength to the concrete. So inhibition of cracks has to be stopped. The formation of cracks should be stopped. So we use the polythene or polyester lenticels or fibers. But here, when adding those fibers, it needs extra water for workability. So again, the workability thing is addressed, and the inhibition of crack method is being widely used as fibers are being used in this case of concrete. Next method, the last method we have is sulfur impregnation. This we have already learned in sulfur impregnation concrete, where the entire concrete will be manufactured, and it will be immersed in the molten sulfur, and it will be then it will be vacuum cured and then it will be used. So this is kind of concrete which is made with sulfur impregnation will have a strength up to 58 megapascal. So this is another method. So these are the manufacturing methods which are available for high strength concrete. Next, coming to the characteristics of high strength concrete. As we said, the workability, it will be very low workability. For the to overcome that, we'll be having adding super plasticizers. The strength is like for high strength concrete, the strength gained during the initial 24 hours is 20 to 27 megapascal, whereas ultra high strength concrete, we have gaining strength in 12 hours around 42 megapascal. So this is another indication that you within 1 day you can see that the compressive strength is gaining momentum in case of high strength concrete. And here the durability is low for high strength concrete, and the high cement content has been as we said, high cement content is being used, and the creep failure is avoided, and we have the stress strain relationship also. We said that the initial curve will be very steep in case of high strength concrete. So these are the characteristics of high strength concrete. So coming to the advantages, achieving high strength is the main aim. So the advantage is that it has high strength. It reduces the construction time, and it is more economical in high-rise constructions. It reduces the self-weight of the structure, and it increases the carpet area. The thickness of the cross-sections of the concrete members will be very thinner in case of high-strength concrete. Thereby, it increases the carpet area. Reduction in creep, as we all know, the time-dependent deformation. Even after a long time, there'll be no creep seen in the elements. Reduction in deflection and increase in durability of structure is the advantages. Coming to the disadvantages, it cannot be used when the members are subject to freeze and thaw cycles. When under frozen conditions, this high strength concrete cannot be used. Strict quality control measures are to be enforced in the site. The materials used for HSE should be selected carefully. That is one another disadvantage. And applications, if we see, mostly it is used in high-rise buildings, columns and beams, and multi-story buildings also it is being used. And flooring, for flooring in chemical and food industry and bridge deck overlays, it is being used in case of flooring when it is used as flooring. And seawater construction places also this is being used. So the uses and the applications are almost the same. So this high strength concrete is gaining momentum for the past 5 to 10 years, which means that it can be where you want higher strength for the concrete buildings, you can use this kind of high strength concrete. The cost is a little high, but it is very useful, and it has been applied in most of the places. The construction is very rapid in case of high strength concrete. So this is about high strength concrete. See you again for the next session. Thank you.